Noviembre 18. Miércoles, y hoy estamos en el laboratorio de ciencia con la señora Ferguson y estamos trabajando en el laboratorio de fuerza y movimiento. Y hoy vamos a estar trabajando diferentes estaciones aquí, en el cual si entra en el salón de Google Classroom podrá ver la diapositiva en el cual tenemos todas las estaciones que vamos a estar trabajando. So, good morning, today is Wednesday, today is Monday, right? And we are in Ms. Harrington's lab. You'll be able to find the lab that we're working on with each station in Google Classroom. Okay, today is the 50th day of school. That's why we're wearing what we are wearing. Yep. Okay, and so if you're just joining us in Google Classroom, or if you're just joining us in Teams Meet, you'll be able to see that we are here in Ms. Harrington's class, and we're going to be doing some stations. If you have these materials at home, you might want to look through the PowerPoint and follow us, okay? So if you're just joining us, it's okay. You can go back and look at the video from the beginning, and then just go along with us, okay?
Okay, so if you have a lot of these use toy cars because it's about force and motion. So if you have some Matchbox cars and track at home, you will be able to do many of these yourself. And a lot of fun it's going to be today. Okay, let's get started. So I started to introduce station 1. So I'm just going to, can you just follow me with the camera and then they can see what it looks like?
Yeah, but that is not working.
Well, I think I need to keep going. So, station 1 I'll just switch it over, you mean.
Okay.
All right, well, can't do it. So, station 1, there are 4 different surfaces. We have wood. We have sandpaper, felt, and then we have just a smooth, regular plastic surface. So the question, the scientific question at this station is, how does the type of surface affect the force needed to move an object?
So, ¿cómo afecta el tipo de superficie, la fuerza de cómo se mueve un objeto?
Okay, so we are going to use a spring scale, and we are going to measure in newtons. That's the amount of force, and here's a weight. So what you will do is set the weight down and hook the hooks. And you are going to make sure that the end is facing up. You will drag it, and when you get to the, whoops, they get caught. When it gets to that line, stop and read whatever is on the scale. So you will do that. There's a data table, which I can show you here. So we have this table that has the name of the surface here, and it says trial 1, trial 2, trial 3. So in each of these, you will do 3 trials. Can anybody tell me why we do 3 trials and not just 1?
Can you hold this here real quickly? Yeah, so I can fix the...
So, oh, there we go. So, anybody know why?
Why do we do three trials? ¿Por qué hacemos 3 veces? ¿Por qué hacemos 3 pruebas? Dígame. To verify?
That's a good answer.
Esa es una buena contestación.
Yes.
To measure it?
To measure it? All right. So normally what a scientist would do is they would do the same thing 3 times to see if they get similar or same results.
So normalmente un científico lo mide 3 veces para ver si obtiene los mismos resultados o resultados similares 3 veces.
Okay. And at the end, they actually average them and get an average score. And the way you average is they would add them together and divide by that number.
So al final, toma los resultados y los suma para tener como un puntuaje estándar para ver, ¿verdad? Cuál es el puntuaje estándar de los de lo que obtuvo.
We're not asking you to do that.
No le estamos pidiendo que haga eso.
Because you don't know how to do it yet.
Porque usted no sabe cómo hacer eso todavía.
Okay, so next, I told you so. We both at the same time. All right, we're going to the next station.
Vamos a la próxima estación.
So, this one,
Esta, la próxima,
does the height of the ramp affect the speed the car travels?
la estatura de la rampa afecta la velocidad en el cual el carro viaja.
So, what variable did you change? What variable did you measure?
¿Qué variable usted cambió y qué variable usted midió?
So, the question is, does the height of the ramp affect the speed the car travels? So,
La pregunta es, ¿la altura de la rampa afecta la velocidad en el cual el carro viaja?
so the first thing, we have a car.
Lo primero que tenemos es un carro,
You have a timer.
tiene un reloj,
And you will set it up. One person will be the timer, one person will drop the car, release the car. So you will go, ready, set, go. When you say go, all you do is push the big blue button. And then when the car stops, you hit it again and then record how many seconds. And then push both to clear. So here's an example of that over here. Yesterday we did, the ramp 1 is 3 centimeters high, ramp 2 is 6 centimeters, ramp 3 is 9 centimeters. And if you look there, trial 1, trial 2, trial 3. So they did it for each one 3 times, very quick. You saw how fast it is. So you're going to enter your data in here very quickly. Boom, boom, boom. You probably will not get all your answers to your questions right away. Those we will probably go back. And by the way, we're going to do this when we come back after vacation. So don't panic that you have to do all 6 today. We'd rather you did a good job and learn from it.
So no tiene que hacerlas todas hoy. Si usted está en línea, yo le pido que por favor, si tiene un carrito en su casa y puede hacer este proyecto, usted hágalo en su casa y usted entonces va a grabar sus propios datos. So para mi amigo Gustavo, si tú tienes tu propio carrito en tu casa y tú puedes hacerlo tú, o Carol, o mi amiga Carla, o mi amiga Ariana, o Jess Feliz, y puedes hacer esto con tus propios materiales, te pido que entonces lo hagas, ¿ok?
Okay, so this one, that center 3, is how does the amount of force exerted on a car affect the distance it travels? What do we change? What do we measure? So let's talk about that.
Okay, so vamos a hablar sobre cuánto afecta la distancia de cómo un carro viaja, la fuerza, qué es el variable, qué cambió, qué fue, cuánto podemos medir.
So usually in the scientific question, you can answer both of those. I'm going to give you a hint. Does the amount of force exerted on a car? So what is the thing that we're changing?
¿Qué es lo que estamos cambiando?
I just told you. The amount of what?
La cantidad de qué?
Amount of force.
La cantidad de fuerza.
And usually after the word effect, it tells you what you're going to measure.
Y después de la palabra afecta, ¿qué viene? La palabra qué?
So in this case, the distance.
La palabra distancia.
It travels. So watch what you're going to do there.
Mira lo que vamos a hacer aquí.
So again, all set up for you. And we have this long track.
Tenemos esta pista.
I got to find the tape measure. Right here. We'll set this up.
Si usted tiene una pista en su casa,
So on this one,
esta pista.
can you hold this? Put it right where the blue begins. You have to be careful not to release this because it will hurt if it's metal. So we're just going to set it next to the track. make sure it's straight.
Porque tenemos que asegurarnos que la pista esté derecha si la estamos midiendo.
Okay, you can just let go.
So we can measure it correctly, you said?
Yes. So where we got one. Is our car in here? Oh, checking yours. Car? Might get stuck in another one. Here it is.
Okay, ¿esto está derecho? No. Arríbalo.
Okay.
Arríbalo de la cruz, mira.
So this one, we're gonna slide this down to here.
Para que esté derecho todo.
Okay.
Sí.
So there's a launcher
Sí, ahí en el medio también.
on here. Well, that.
En el medio.
All right. Let's see if this will come all the way down. And it might. You stay down. I'm just gonna. Oops, sorry. Okay, we'll try this. Okay. Can we see the launcher on there?
Yes.
Okay, so there are little slots on the launcher. There's a 1, 2, and a 3. There's 3 different slots.
Okay.
Guys, why don't you guys come?
Parece, para que pueda ver lo que ella está hablando.
Don't get too close. People sit on the floor.
Súbese en el piso.
So,
Ahí hay algo que se sienta en el piso. Francisco, que se siente en el piso.
So we won't
Mueve el pie.
So the very first, so you line it up by the nose of the car. And the first one we're going to do, this is how it launches. You pull it to,
Okay, but wait, let me hold it. So that-
okay. There we go. So we have position 1, position 2, position 3. All right, so we're going to start with position 1. You can see on here, I'll move those out of the way. Position 1, trial 1, trial 2, trial 3. So you're going to pull it back to the 1, bring it here.
So before you let it go, I want to go all the way back though. So I can see it from the bottom.
Okay, well, you won't, this one's position 1, we won't go that far.
Okay, so let me see.
Ready? Okay, so you release it, and then we're going by the nose of the car. This is 3 feet, about 4 inches. So you would put just 3.4 inches, okay? Then we do it again. You're gonna see how fast this is. 1, let's try 1. Trial 2. Okay, and trial 3. Ooh, they're all pretty close, right? So are we going to take a long time doing this? No. It should be very quick, and everybody should have a turn. So I'm going to put on the 3. So I just want to bring something in. When the rubber band is stretched back, that is called potential energy. That is the potential to, energy is the force of motion, right? So that is the potential for motion. So there's a lot more potential in an extended rubber band than one that is not. So watch this. Do you think it's going to go further?
Yeah.
If you think it's going to go further, raise your hand. Okay.
¿Usted cree que va a ir más lejos porque el rubber band está más para atrás de la mano?
Okay, so let's measure it, line it up by the nose of the car. So, let's count backwards, maybe it's second.
Vamos a contar para atrás.
5,
5, 4, 3, 2, 1.
And we lost track, definitely. So it goes further than however many feet this tape is. So pretty exciting. That is kinetic energy.
Esto es energía cinética.
So potential was before I push the button. Is there more or less potential energy in step 3 than step 1? The first one, which has more potential energy?
¿Cuál tiene más energía potencial? ¿La 1
or 3? Or not 3? 3. And the way you know is it pushed it a lot further. It had more force.
And it lost track.
Okay, so you're going to get to try all of these yourself. So we're going to go, let's quick look at the next one.
Vamos a la próxima.
Once I do the teaching, you're going to go back and do the proving. Okay, you can look from here. Better than okay, this one. Read the question, please. Oh, camera. Now hold it. You can hold it up.
Does the same mass of does the mass of a top of plastic affect how long it spins?
La masa de un topo afecta qué tanto da vuelta, qué variable cambió, qué estamos midiendo.
Well, went out of order, but sorry. So there are 3 people. Everybody, this is how you turn these on the side. Turn them on. Okay. Here we have 3 different tops, all identical except for color. And there's one other thing I changed to increase the mass. Do you know? Can you tell them what it is? What are those? No? Do you know what those are called? Anybody? Do you know what these are called? Washers. So these metal washers, we have one with we have one with 1 washer and one with 2 washers. Which one has the greatest mass? Which one? The one with 2, the green one. You're correct. And this has the least mass. How do you know that?
Because it doesn't have this one doesn't have so it's not heavy. This one's kind of heavy and this one's heavy.
Right, so the more washers, the more mass. Good. So this is how you spin the top. You pinch it, and you go just like that. So you are going to, each person, when you spin it, you will hit this and you will time it. When it stops spinning, you'll write it, you'll record it on your data table. Okay? It's still going. Me? No. Okay. Next. I'm going to clip this up here. And this is called centrifugal force. This is a force, oh my goodness, people call us. So, over here, number 4. Does the size of a magnet affect the distance it can be apart and still push, repel without touching? So why don't we again stand up, avoid the track. I'm going to show you, everybody, I'm going to go upstairs, you can see the okay. So, this is I'll be back. Yep. We have small, medium, and you notice I have the north side. In order to repel, left sides repel, opposite sides do what? It's a magnet. Opposite sides. No, it begins with letter A. What's that called?
Attract.
Attracts. Thank you. Opposite, this is south pole, north pole. They attract. That's how you know which one. North and north, they're repelling each other, right? See, it wants to be attracted. It doesn't want to fight. So, let's see. Whoops. Got it. So small, medium, large. And this is how you measure. So the first one you go, see, starts to move. Okay, you stop it there. You take your ruler and you measure in centimeters. So this is about 2 centimeters apart. Okay? And then 3 trials. This one, watch this. I'm going to push so I feel it repel. Ooh, you got to do it a couple times. Ooh. Wow, this one is. And this is even less.
The bigger it is.
And watch this one. And that one is further apart. Okay, so do you see what you're going to do? And what you will see, because look at this one. This one is even smaller than this one, but watch this. Okay, so that one. So I want you to do that and watch this one. This one, oops, so I gotta flip it over, because these are different, watch this. Whoa. Okay, so that one, is that a stronger magnet than this one? Yes, look at that distance, now look at this distance. Ooh, we got all kinds of power here.
Yeah.
So, okay, where does it stand? Right there. Okay? So you're going to measure the distance and then answer the questions. Small, medium, they're crazy. Okay. So, last one. So after there are lots of questions, but we can address those the next time. So again, trial 1, trial 2, trial 3. Magnet, small, medium, or large. So what are we changing? In this column is always what we're changing. The size of the magnet, right? What are we measuring? What am I measuring with the ruler? The distance, right? So flip that up there, please. And let's go to the last one. So walk this way around the table. Okay, watch out for the right track. Go ahead to that table. Oops, we'll see you on the ceiling and everywhere else. Okay, aim it at the table. Okay, ladies and gentlemen, and this, I love it. You guys on the other side, please. All your stuff. So, somebody read this, please. Height.
Height of the inquiry.
Okay.
Whether the marble can make it around the loop or not.
So, can you put on there? Put it up there for me. So, you need to move, please. I need the space. Move your computer. Move. Okay, so I tried to make the loops the same size, pretty much same size. Yes, Mrs. Walden. Okay, so what you're going to do, let's see, this one is a little longer, so we're going to go this way. So you're going to tape it. Excuse me, back up, please. Back up, please. Thank you. So one of them should be about this height, and you're working with a partner, so you don't even have to. This is 1 foot. This is 24 inches, this is 12 inches, okay? So this is a good measure. Catch it in the cup. So there's 2 people in the group. One person can hold the cup. Okay, so you should do 3 trials at this height. Maybe 3 trials at this height. And maybe you should, using a meter stick, find one like this to see. So what are you measuring? Yes or no? Does it go around the loop, right? Mm-hmm. So give me the marble, please. Hold the cup, please. Somebody. Okay, so I think you can probably hold it. We'll have a meter stick. I'll tape a meter stick up here for you. And then, no. Okay. This one right here, let's see. Whoa. Back it up, please. And then back it up, please. Back it. Thank you. Oh, so you gotta find. So you're gonna mess around with that, and then you're trying to find what is the perfect height, right? Is it lower or is it higher? Well, it doesn't quite make it around, so maybe. Oh. All right, so you see, you're gonna try and get, 3 different heights, and I will tape a meter stick to this so that you can actually tape it on there. So you could tape one here, right? So you could, I think we could do the 3 trials better if we did it this way. And then I will tape one there, and you can make a 3rd one that's way high. All right? So anyhow, you are gonna go back to your station. It's gonna take a bit of time. Don't dilly-dally. Do 1, 2, 3. Do your 3 trials, one after the other, and record your data. Okay? Everybody needs a turn. All right, go ahead.
Okay, so we are going to continue doing this lab. So what I'm going to ask of you, Gustavo, is to look at the Google Slides. I'm going to stop recording right now, but I'm going to leave you with one of the guys in the group, and then if you look at the slide and you have the materials at home, then you can try to do these at home, okay? Si tienes materiales en tu casa y puedes seguir el PowerPoint, entonces puedes hacer esto en tu casa. Si no, pues entonces puedes mirar cómo se hizo cada uno de estos proyectos mientras el señor lo está explicando y puedes escribir tu nota, ¿ok? Gracias.
Una.
Okay.